Howdy everyone, Mr. Reed here, and welcome to One More Question. So what we're going to be taking a look at today is just exploring the base function f of x is equal to square root of x. So that will give us an idea of graphically, that's how I'd like to explore it, I guess, graphically how this thing's going to look, and then afterwards we'll do some transformations of it and do some other stuff with radical functions as well. But for the time being, if what you're looking to find out is how the square root function behaves, you're in the right place. Let's get to it. Okay, so it's a pretty easy question up above, or simple maybe. All we're going to be asked to do here is make a table of values and graph the function f of x is equal to the square root of x. Now, I decided to be brave this time, and I didn't set up a blank graph, so I'm going to be freehanding it. Don't send me hate mail. I'm no artist. I'm barely able to make symbols, so this is going to be a little bit rough. Probably should have thought this through a little more. All right, long story short, let us actually do a table of values. So in this case, I would have x for my x value, of course, and then root x for my y value. You could say f of x would be the same thing. So I'm just gonna throw down, I'll tell you what I usually do. I go -2, -1, 0, 1, 2. Those are pretty much my go-tos. I'm gonna be really sad with this particular set of values. There's a couple of them that are really nice and helpful. One that's okay, and then two that are, well, kind of good to know, but you'll understand in a second. So first thing, let's take the -2 and put it inside of square root. That's imaginary, or at least not something that's in the real number system. So we are not going to be able to evaluate this on the Cartesian plane, which is going to be what we're graphing this on. So no value. Next up, square root of -1. Well, that's another negative, so that's a big no. So there is nothing out on the left-hand side of the y-axis. So all those x values that are negative, including the ones that are past -2, none of those are going to work. Square root of 0 is 0, though. That exists and definitely gives you that value of 0. That's perfect. Square root of 1 is 1. That's another nice value. Square root of 2 is, well, most people would just say it's root 2. So root 2 is, if we're being really rough, about 1.4. And so kind of okay. I don't know if it's real helpful for graphing, but we might notice something. Well, wouldn't I just want to take values whose square root is nice? Well, let's do that then. Square roots that are nice. 4 has a nice square root. That would give me 2. 9 has a nice square root. That would give me 3. Okay, I have a reasonable number of values now, so I can go ahead and try this thing out from a graphing point of view. So, as I said, no artist. Really sorry for this. So that is a Cartesian plane. I'm going to put a point right here at the origin, which is what I'm going to call 0, 0. Now, I'm going to go over a little bit. I'm going to say right there is going to be 1 unit. And so that's going to be up 1 unit, so maybe something like that. And I'm just freehanding it, but it will give me a good picture of the overall shape. And I'm going to go here for 4. If that's 1, that's about 4. And then I'll be up 2, so somewhere around there. And then I'm going to go over to 9, which would be about right there. And then I'm going to go up to 3, which would be about that. So this would be 0, 0, and then, 1, 1, and then 4, 2, and 9, 3 as my points. So I'm going to kind of make my function curve through those. As you can tell, it's going to flatten out as it goes further out to the right. It's going to be 16, 4, and 25, 5. It goes out quite a ways without growing a whole lot. You might recognize the shape, though, too, especially if you've been following along with the idea of the inverse from some of my previous videos. So if you had been tracking along with that, then you might say, oh, this looks like a sideways parabola. So this is like top half of a restricted domain parabola. Yep. And you might have even seen this from an algebraic point of view if you'd done some of that work, because when we rearrange a squared function by, first off, we switch our x and our y values, and we resolve the thing for the new y, we're going to get square roots, and we're going to get plus or minus square roots because you're going to have top half, bottom half. If you restrict the domain, you get either only top half or only bottom half. So a square root function on its lonesome with no stuffing or jazz that goes around it is just going to be plainly top half of an x squared parabola that has been put onto its side, but top half only, so we're restricting that parabola to the x greater than or equal to 0 domain. Cool, so that's what it looks like. Looks like a familiar object just placed on its side. And so that really is the start of our understanding of how the square root function is going to be. Now, from here on out, next thing that we're going to do is pile in some transformations. But if you're comfortable with transformations, that part's not going to shock you. So I might get around to doing that one a little bit later, but for the time being, this should get you to a place where you can play around with transformations and see how that will go. All right, folks, if that one was good, like, subscribe, and as always, take care.